go through some hard A star predicted questions. Just pop up that chat. Alright guys, I think we are live. Let me give it a second, just for everything to load up. I think we're all good. If anyone's joining on TikTok, guys, we're going to be doing A-Level Maths Paper 2 predicted questions on YouTube. Just making sure everything's good. If anyone is in the YouTube chat, give me a thumbs up. It's tomorrow, so I'm trying to fix it if you're not feeling good, but I'm sure you guys are all very prepared. I'm sure you guys are all very, very prepared. Yes, King. That's good to hear. That's good to hear. At this point, I'm sure you guys are more than ready. Definitely gonna get that A or the A star that you guys need. We're gonna go through 6 questions today, all predicted topics for paper 2. Bit of parametric integration with partial fractions, bit of first principles, inverse trigonometric functions along with implicit differentiation, bit of trig modeling. Trig modeling, we are 100% sure is gonna come up. This is Edexcel Maths, guys. Edexcel Maths. So we are sure about trig modeling. It's gonna happen. If it's not trig modeling, it will be partial fractions. It's gonna be one of the two, and we are gonna see it in differential equations, or we're gonna have to integrate those partial fractions. And then geometric series, guys, I have 2 questions on geometric series, just because I wanted you guys to feel not very intimidated by that summation, that weird summation notation that they use, which tends to trip people up. It's not difficult, and I'm going to show you guys that it's not difficult. We'll be starting in just 2 or 3 minutes, just going to give people a chance to join, especially if I see Pax in the chat, I'm ready to go. Just going to make sure the YouTube stream isn't crashed or anything. Alright, cool, we are excellent condition, that's good to hear. Do I have anyone on TikTok, live on YouTube? Thanks for carrying. Guys, if the videos are helpful, if the stream is helpful, it's up to the channel. Give it a like, do whatever you can. I'm gonna have to plug myself. I do hope the videos are helpful, guys. Do hope they are useful for maths and chem. But yeah, let's see if we can even predict some of the questions exactly coming tomorrow. Probably won't be able to, but we'll give it a go. We got quite close to paper 1. The substitution was very similar to one I did on the live stream, so we'll see, we'll see. We are going to start off with a first principles question, guys. We're going to be starting it at 8:05, 5 past. Same as always, we wait 5 minutes for people to join up, then we'd go in. Let me know if anyone's in the chat. Give me a thumbs up if you're ready. Let me know how you're feeling for paper 2. PSK, you saved my grade. I doubt that. You saved your grade. You put in the work. I just made the videos, alright? If you saved your grade, you're the one who's doing that. Now, guys, you're saving yourself. You're saving yourself. You put the work in. You do the revision. I just make some videos, alright? Hope it's a good paper. I mean, we're thinking it's going to be very similar to 2022 because, I mean, the format, the structure of the questions and the topics, so similar to 2022. If you guys want to be doing the questions along with me, going to be starting in just 2 minutes now, 2 minutes. Just making sure the stream isn't crashing or anything. Also waiting for Pax to join up. So, okay, we got a thumbs up already. We got a thumbs up already. In 2 minutes, guys, we're going to be starting. Got 6 questions for you guys. Should be very helpful. I would expect most of these to come up tomorrow. And if not, the questions we did yesterday are also incredibly relevant. Should you do vectors? I wouldn't prioritize vectors. I'd definitely prioritize the stuff we haven't seen at all. We did see a vector question, so I wouldn't prioritize vectors. If you've done everything and you want to do a vector question, go for it. There's no harm. You never know what Edexcel are going to do. They could put more marks on a certain topic this year. Yeah, differential equations, we're almost 100% sure are going to come up. Almost 100% sure. Looks like Harvey might know me. Harvey might know me. But yeah, guys, just one more minute. Looks like we're all good. I'm going to be starting in just a second if you guys want to go through these tough questions with me. Also going to be addressing some key misconceptions like with cobweb diagrams, staircase diagrams, any of that stuff. Is r cos theta plus alpha going to come up? I do have a feeling it's going to come up, to be honest. They love to put trig modeling in, using that answer to part A in answer part B or C. They love to do that in these kind of questions. So I think it could come up, but no guarantees on anything. It's Edexcel's decision, not mine. With differential equations, they come up every year for big marks. The fact that we haven't seen it yet is going to be involved in most likely some partial fraction question. We're doing 6 questions today, so however long the 6 questions take. The parametric integration question that I have is long. It's very long. Trapezium rule could come up, but the thing is, Trapezium rule is just using a formula. They don't love to put big marks on formulas because it is just complete memorization. They're not testing your thinking, so they're not going to be putting like Newton-Raphson. They're not going to give you a massive mark question on that just because it's a formula. They might do trapezium rule, they might do it, but it probably won't be for big marks. We're going to focus on what's going to be for those big markers at the end of the paper. Only doing hard questions. Guys, I'm doing stats. I'm not doing any mechanics. I'm going to do only stats. I'm going to be your guy for stats. It's just on YouTube. My laptop cannot run can't run TikTok and YouTube streaming, so I can only do one at a time. Okay, guys, it is 5 past. We're going to be going now. All right, first question of the day. You guys probably have seen this first principles question before, but let's just go through it. So we have to prove from first principles that derivative of 1 over x is minus 1 over x squared. So first thing we're thinking, guys, remember that first principles formula, okay? So scroll on now. So 1 over x is our function of x. Recall the formula, guys. F dash x or dy dx, same thing, is a limit as h tends to 0 of f of x plus h. Remember, guys, f of x plus h, that means instead of plugging in x into our function, we plug in x plus h. It's not 1 over x plus h, it's 1 over x plus h. Common mistake a lot of people make. Minus f of x all over h. Our function of x is just 1 over x. So we're just going to plug this in, guys. Plugging it in, we have 1 over x plus h. As I said, do not add h on the right. Put x plus h into your function. So if it's sine x, it would be sine of x plus h, whatever they ask you to differentiate. And then we're taking away our function of x, which is just 1 over x all over h. Now from here, guys, do what you can do. Looking at this, there's not much we can do besides just subtracting the fractions. But in order to subtract fractions, GCSE stuff, we have to get them under the same denominator. So we're going to multiply the left fraction by x and multiply the right fraction by x plus h, okay? So simply just multiplying through to get them over the same denominator. So just focusing on the numerator, guys, we're going to ignore that h in the denominator for now. We have x because we're doing 1 times x. Take away, then we have 1 times x plus h, that's just x plus h. All over x times x plus h, okay? From here, we can just subtract. So we have x minus h. X minus x, that's just 0, and then minus h. So these x's will cancel out on our numerator. That leaves us with the limit as h tends to 0. I just want to say, guys, with these questions, you don't actually have to write the limit as h tends to 0 every single time, but I would. Personally, I would because it takes 2 seconds, and you never know how strict they're going to be. But normally, the key thing is at the end. Normally, the key thing is at the end, guys. So we take the limit as h tends to 0 of minus h, because that's what we have left, over x squared plus hx, and all of that, what we found in the numerator, is over h. So guys, the whole thing divided by h is the same as timesing by 1 over h, so we're going to multiply our denominator by h. So we have the limit as h tends to 0 of minus h over hx squared plus h squared x. From here, we can cancel out all the h's. So cancel out that h on the numerator, cancel out the h's on the denominator. So we have the limit as h tends to 0 of 1 minus 1 over x squared, because we get rid of the h's, plus hx. Now we can evaluate the limit as h tends to 0. Pax is here, great to hear. So we evaluate the limit as h tends to 0. So as h tends to 0, hx will tend to 0, because that's x times 0, or something that tends to 0. That will leave us with minus 1 over x squared. Exactly what we needed to prove. Pretty easy question, guys, to start off the stream. But some of you may not have seen this first principles before. Give me a thumbs up if you want the next question. And I hope everything is good with these first principles questions. I hope that's all good, guys. I hope that's all good. Give me a thumbs up, guys, if you want me to move on. I'll make sure the stream is still not crashed, because my laptop is getting very, very warm. Alright, looks like we're all good. Next question, guys, is going to be an inverse trigonometric functions question. Alright, I'm seeing some thumbs up. Alright, good. We're going to have inverse trigonometric functions. They don't normally examine this, guys. They don't tend to examine this stuff. However, I'm seeing loads of thumbs up, so we're going to carry on. They don't tend to examine this stuff. But I would say the only reason they don't is because people can use their graphing calculator and just put it in the exam. However, part B is an implicit differentiation question, so we're just going to do part A while we're here, okay? I'm only doing maths and chem, only maths and chem this year. So we're doing an inverse trigonometric function, guys. We're told a curve C has the equation y equals f of x, where f of x equals arc sine of half x. We're told that x must be larger than or equal to 2, or less than x must be larger than or equal to minus 2, or less than or equal to 2. And y must be larger than or equal to minus pi over 2, and less than or equal to pi over 2. As we know, these are the conditions for our inverse trigonometric functions. For part A, all we have to do is sketch curve C, okay? So sketching C, guys, remember we can just draw out the sine graph and reflect it in the line of y equals x. However, we do have half x in it, so we have to be a little bit careful. But in general, it is just that. I would say, guys, don't stress too much about part A, but I'm going to walk through it just quickly. So remember, guys, having f of x or y equals to arcsine half x with our given ranges and domains of x and y's. This is the same as taking the sine of both sides. So we have that x or half x equals sine y. We can multiply over by 2, and that will leave us with x equals 2 sine y, which is, as I've just said, the same as y equals arcsine half x. So exactly as I said here, guys, I would just recommend to learn these inverse trig functions if it is a one marker, because you can just use it in your calculator. But the normal sine graph for y equals 2 sine x, just switching the x and y's so it looks a little bit more familiar to us. In between x equals pi over 2 and minus pi over 2, because it's 2 sine y, good thing in general for functions, we know if we have that constant at the front, we stretch vertically in the y direction, okay? So we have y equals 2 sine x, so the maximum possible value we can achieve is 2, the minimum possible value is minus 2. We know at pi over 2, we'd normally be at 1, now we'll be at 2. At minus pi over 2, we'd normally be at minus 1, now we're going to be at minus 2. All we're doing, guys, is reflecting this graph in a y equals x line, yeah? And we're flipping our y and x values. So exactly that, guys. Now we have that pi over 2 and minus pi over 2 on our y-axis, and we have that 2 and minus 2 on the x-axis. And all the way you can think of it is just reflecting the line of y equals x. As you can see, the curve kind of converges towards that 2 and towards that minus 2. It's the same idea here. It still kind of is convex towards that 2, and then also towards the minus 2. I hope I'm making sense here, guys. Don't stress about it too much. I would just recommend to either learn it or use your calculator if you do further maths. We're going to move on to part B because it's a more relevant thing that is most likely to come up in paper 2. So they say that given that x equals 2 sine y, we have to show that dy dx equals 1 over the square root of a minus x squared, where a is a constant to be found. Okay, so this is great. They already give it as x equals 2 sine y. From here, we can do two things, guys. We can either implicitly differentiate, which would just be good practice, or instead of finding dy dx, we could find dx dy, because we already have x to be the subject of the formula. This is a good little trick, because these finding reciprocals and finding dx dy or dy dx is that idea and that connective rates of change. For example, if we want dt dv, it then be dv dt reciprocated. Yeah. So it's just good practice, guys. I'm going to do the reciprocal way, but you could do it implicitly, gets you the same answer. So we have that x equals 2 sine y, as I said, either implicitly, or we can find dx dy, okay? Because we have x as subject of the formula, we can find dx dy, and we don't have to do it implicitly. Hope that makes sense. So from here, guys, I found dx dy, differentiating 2 sine y will just be 2 cos y. Then to find the reciprocal of both sides, because we want dy dx, not dx dy, we have that dy dx equals 1 over 2 cos y, okay? So from here, guys, we can compare what we have to what we need to get, okay? So exactly as I said, compare what we have to what we need. We can see, going back to the show that question, we have only x's in our function, or in the show that of dy dx, okay? Only x's. Right now, we have 2 cos y. We currently have y's, we need all x's, okay? We are going to be going over parametric and Cartesian. I have a massive question on that. So we need to find a way, guys, to connect this x equals 2 sine y to what we currently have, which is 2 cos y, okay? So exactly that, guys, we have x's and I'll show that, so we need to link it cos y to sine y. What trigonometric function do we know that links our causes to our sines? Cos squared y plus sine squared y equals 1. We currently have cos y, but we need it in terms of sine y in order to get x's. So first things first, we know that sine y equals x over 2. Because we know that x equals 2 sine y, we can divide over by 2. So x over 2 equals sine y. Okay? So we know that cos squared y equals 1 minus sine squared. We can rearrange this to make cos y the subject of a formula. So just cos y, not cos squared y, we'd have the square root of 1 minus sine squared y. But we know, using the information that they gave us in the question, that sine y equals x over 2. So we can simply plug in that x over 2 into our cos y equals the square root of 1 minus sine squared. Okay? So instead of sine squared, we have x over 2 squared. Okay? So from there here, guys, all we have to do is sub it into our cos y of dy dx, because remember, we're trying to get to an answer that only has x's in it. We don't have any y's, we're going to have to make that substitution. If it lets me scroll down, there we go. So making the substitution in, we have 1 over 2 times, and then for cos y, the square root of 1 minus x over 2 all squared is going to be x squared over 4. So then from here, this will be dy dx. But let's compare back up to what we had before, okay? Back, back in our original answer, guys, we don't have x squared over 4, we just have x squared. So we're going to have to take out a quarter from inside the square root, and then eventually take it outside of that square root. So we're going to have the square root of a quarter to be taken out, to be just left with some constant, take away x squared, okay? So taking out that quarter, guys, we're going to factor out a quarter, if it lets me. So factoring out that quarter from the x squared, just focusing on that denominator, guys, we'd have 2 over root 4, and then we'd have 1 divided by a quarter, it's going to be 4, then x squared over 4 divided by a quarter, or factoring out that quarter will just leave us with that x squared. So we factor out that root 4, so we have 2 over root 4 multiplied by the square root of 4 minus x squared, okay? Root 4 we know is just 2. Remember, guys, don't stress about these plus minus 2s in these show that questions, okay? We know the square root can be positive or negative, but in these show that's, don't start overthinking. Just remember we're trying to get to that specific answer that they gave us. So don't be stressing too much. So in our denominator, we're going to be left with 2 over 2, it's just 1. So that'll be 1 times the square root of 4 minus x squared. And that's exactly our answer, guys. We have that dy dx equals 1 over the square root of 4 minus x squared. Therefore, our value of a that we had to find was simply 4. So nothing too tricky, guys. Nothing too tricky. But I guess factoring out that square root of a quarter can be a little bit weird. Moving on to part C, we're told that point P lies on C and has y coordinate pi over 4. This is great. We already have the y coordinate of P. It's quite friendly of them. We have to find the equation of the tangent to C at P. Okay, so we're going to have to find dy dx at P. Okay, we have to write our answer in the form of y equals mx plus c, where m and c are constants to be found. So we're going to use our straight line equation. I'd always recommend to use y minus y1 equals m times x minus x1. Tends to be easier, and you can just plug numbers in. Tends to be a bit easier, in my opinion. But don't worry, you can use. Yeah, this is still useful if you do AQA. This is still useful. It may not be the same topics coming up in paper 2, but it's still useful. So guys, the first thing we're going to have to do is we know that y equals pi over 4. We're going to want to find our x. We know that x equals 2 sine y. So all we have to do is plug that pi over 4 into our 2 sine y to get our x coordinate. Then we can also plug in our x coordinate into dy dx to then find the gradient. Plug that all into our straight line equation. Because it's tangent, it will just be the gradient that we find when plugging this into dy dx. However, if it was the normal, we would have to find the negative reciprocal. So maybe just underline tangent or underline normal in these kind of questions. So plugging in pi over 4 to find that x coordinate. So y equals pi over 4, we have x equals 2 sine y. Pi over 4 is that beautiful angle where sine and cos of pi over 4 is root 2 over 2, and then tan of pi over 4 is 1. It's quite a nice angle, guys. So x equals 2 times sine pi over 4. Pi over 4 of sine or cos. Sine pi over 4, cos pi over 4 is root 2 over 2. We multiply it by 2, so we get left with x equals 2 times root 2 over 2. X is root 2. So we now have our y coordinate and our x coordinate. Now we just need to find the gradient. So into the answer that we found for part B, all we have to do is plug in x equals root 2. So we have 1 over the square root of 4 minus x squared. Root 2 squared is just 2. Okay, so we get left with 1 over the square root of 4 minus 2. That's just 1 over root 2. So we have our gradient, we have our y coordinate, and we have our x coordinate. Plug them into the straight line equation. Y1 is pi over 4, x1 is root 2, and m is 1 over root 2. Okay, expand it out, add over that root 4. Oh, sorry, add over that pi over 4. We have that y equals 1 over root 2x, just expanding that out. And then we have 1 over root 2 multiplied by minus root 2 is just minus 1. And we're going to add over that pi over 4 onto the right hand side. So we have minus 1 plus pi over 4. I'm going to leave it like that, guys. Because going back up, they wanted it as constants, okay? So if we had this recurring decimal with pi over 4, we wouldn't want it in that form. They wanted it simplified and very clear, so we have it as minus 1 plus pi over 4. Fred is back. I'm happy to hear Fred is back. Guys, give me a thumbs up if all of this question makes sense. Don't stress too much about the inverse trick because they tend not to ask that. The key thing is that we can rewrite it as x equals 2 sine y, so the maximum minimum values that our function can achieve is 2 and minus 2. And then we reflect it in that y equals x line, flipping our x and y values essentially. So guys, give me a thumbs up if that all makes sense. As the next question is the parametric integration question. It's a good one, I would say. Definitely something like this could come up tomorrow. Definitely say so. Let me know if you guys have any questions about this. I think part C is pretty straightforward. Part A, they probably wouldn't ask. But let me know. I'm gonna make sure the stream. My laptop is getting very hot, guys. I hope it's alright. Okay. Guys, if the videos or the stream is helpful, please subscribe. I'll be very grateful, very, very thankful. As we're live on YouTube for anyone on TikTok going through questions. Pax is happy, M's happy. Everyone seems pretty happy. All the regulars are back, guys. I hope these are helpful. Nothing too tricky here, guys. Remember when we factor out of that square root? Same thing with binomial expansion questions. You have to take that power along with whatever you're factoring out. So sometimes in binomial, we have it in the form of, like yesterday, we had 4 minus x, but remember, with some negative or fractional power, I think it was the power of a half. When we factor out that 4 to get it into the form that we want of 1 plus or minus ax, we have to take that power of whatever we're factoring out. So yesterday it was 4 to the power of a half. Actually, today it was also the square root of a quarter. Tends to be nice values that you can then square root. Maybe not always, but yeah. If you don't know them, don't stress about the inverse trig functions, Fred. I wouldn't say they're a priority, but definitely definitely be aware of them and just know that you're reflecting in the y equals x line of your normal sine or cos graph. Right, guys, I'm going to move on to the parametric integration question. I'll leave it up for a minute if you guys want to have a read. Just leaving up for a minute if you guys want to have a read, guys. What's up, Joe? So, guys, parametric equations with partial fractions, which is what we have in these questions, is going to come up tomorrow. Like, if not both, one of them's going to come up. Parametrics, almost definitely going to come up. Partial fractions, almost guaranteed to come up. It might be part of the differential equation question. It might not be parametric integration, but if I had to gamble, I'd say this kind of topic is going to come up. Guys, let me know if you want me to just carry on or if I should leave the question out for a minute, because this question is quite good. I would say it's very good practice. Gets a lot of key topics that should come up tomorrow, but we'll see. Give me a thumbs up if you want me to move on, or just say move on. But if not, then I'll leave it up for a minute longer. Just let me know, guys. I have seen paper one. I saw paper one. It looked okay. We saw that integration by parts or by substitution at the end. Some weird questions, nothing too abnormal. It was very similar to 2022. I will say that. The paper was very similar to 2022, same structure. So if you guys haven't done 2022 paper 2, I would definitely recommend that before tomorrow. But yeah. But guys, give me thumbs up or move on if you want me to start this question. If not, let me know. This is Edexcel Maths. Edexcel Maths, guys. Let me know, let me know, let me know. Definitely a good question, guys. Make sure you know that parametric integration formula. The chat is a bit delayed for me, so sorry if people are already putting in easier than my paper. Um, I'm not sure because it's hard to tell after the papers. Everyone's always so confident on TikTok, so you never really know. Start question. I got you. Alright, I'll start reading through it, guys. Sorry, my hay fever's killing me. So we're told the figure above shows the curve with parametric equations x equals 1 over 1 plus t and y equals 1 over 1 minus t, where t must be larger than minus 1 and less than 1. We're told the region R, shown here, shown in the shaded figure, is bounded by the curve, the x-axis, and the straight lines with equation x equals 2/3 and x equals 2. This is very nice of them, guys. They're already giving us our limits in terms of x. For parametric integration, we know we're going to have to change those limits. Okay, so carrying on, we have to show that the area of R can be found by the parametric integral with upper limit a half, lower limit minus a half of 1 over 1 minus t multiplied by 1 plus t squared and integrating with respect to t. And then we have to find the exact area of R. Guys, this is a very good question. This is a very, very good question. So first thing we have to do, guys, recall your parametric integration formula. Whenever we see parametric integration, this is the first thing you're going to write down, or at least know in your head. If you guys are aiming for that AOA start, maybe it just might be instant. You can do it immediately. But we're going to have the definite integral with limits in terms of t, guys. We currently have them in terms of x of our lower limit of 2/3 and our upper limit of 2. but we need them in terms of t, and then we're going to have our parametric equation for y multiplied by dx dt, integrating with respect to t. So first things first, let's change those limits, okay? So we're going to change our lower limit first. We have the lower limit of x equals 2/3. 2/3 equals 1 over 1 plus t. Could cross multiply. All I'm going to do, guys, is just find the reciprocal of both sides. That's the way I'm doing it. You could times that 1 by 3, get 2 plus 2t on the left-hand side, and then rearrange from there. It's all the same thing. So if I found the reciprocal of both sides, we get 3 over 2 equals 1 plus t. We take away 1 from 3 over 2. 3 over 2 minus 1 is just a half. So we have our lower limit to be t equals a half. Remember, guys, if your limit's in terms of t, if you don't have that upper limit larger than that lower limit, do not worry. Okay, you still have that lower limit to be the lower limit, and the upper limit from our x values to still be the upper limit of the t values. Don't get stressed if one is bigger than the other. Okay, if don't get stressed, sorry, if the lower limit is bigger than the upper limit. So changing the upper limit, guys, we have the x equals 2. So we set 2 equal to, if I can scroll down, here we are. So we have x equals 2. So we set 2 equal to 1 over 1 plus t. Once again, I found the reciprocal of both sides. So we have t plus 1 equals a half. Then take away 1, we have t equals to minus a half. That is our upper limit. Yes, minus a half is less than a half, but remember we keep those limits consistent. Okay? And then to find dx dt, going up to our x parametric equation, we know that x equals 1 over 1 plus t. We can rewrite this as 1 plus t to the power of minus 1. Then differentiating and that, we bring that power down to the front, take 1 away from the power, and multiply by 1 plus t differentiated. But 1 plus t differentiated, this is chain rule, guys. 1 plus t differentiated is just 1, because the constant cancels out, and we differentiate d to get 1. So we don't have to stress about that. So we're going to have minus 1 multiplied by 1 plus t to the power of minus 2, bringing that power down by 1. Put 1 plus t to the power of minus 2, get rid of that negative, bring it down to the denominator. So we have the negative of 1 over 1 plus t squared. Okay? So that's our dx dt. We have the limits, we have dx dt, and we already know our parametric equation for y. Plug it all into that parametric integration formula. So plugging everything in, we have our upper limit to be minus a half, our lower limit to be a half. Then we have 1 over 1 minus t, that parametric equation for y. And then dx dt is minus 1 over 1 plus t squared, integrating with respect to t. We can just expand this out, guys, multiplying two fractions, and we can quickly see, comparing it to what we have, don't start expanding out that 1 plus t squared, because we can see in the show that answer, they leave it as 1 minus t multiplied by 1 plus t all squared, okay? So we have everything over the denominator, 1 times minus 1, what happened there? Sorry, guys. There we go. 1 times minus 1, it's just minus. So we have that minus 1 over 1 minus t multiplied by 1 plus t squared. Okay, we're almost there, guys. But once again, comparing back to our answer, we can see they have that upper limit of a half and the lower limit of minus a half. They also have no negative sign. But we know that when we multiply, exactly, when we multiply by minus 1, it flips the limits. It's a key thing to know with integrals, guys. If you multiply everything by minus 1, it flips the limits. Very key for these show that questions. So going back down, multiply through by minus 1. And as I just said, this flips the limits. So we now have the correct limits, upper limit a half, lower limit minus a half, 1 minus t, multiplied by 1 plus t squared, integrated with respect to t. This is great, guys. Tell me how we're going to integrate this, guys. I'm sure you saw the subheading of this question, but let me know how we're going to integrate this. Let me know, let me know. I'm sure you guys already know, but when we see that denominator already factored out, and the denominator has a higher order than the numerator, and it's able to be factored, we're going to be using partial fractions. Those are the key things. Exactly, yeah, exactly. So it's already in this form, so we know it's going to be partial fractions. So we're going to use that partial fractions, guys. Remember, because we have that 1 minus t multiplied by 1 plus t squared, when we're writing out the partial fractions, we have to consider looking at that 1 plus t squared. We have a over 1 minus t, and we have plus b over 1 plus t squared. We also have to consider that 1 plus t not squared. So we have plus c over 1 plus t. From here, guys, we're going to multiply everything through by our denominator underneath, which will be 1 minus t multiplied by 1 plus t squared. I'm not going to take too long going through this. I'm sure most of you can do this. So multiplying through by 1 minus t and 1 plus t all squared, we have that 1 equals 1 plus t squared a plus 1 minus tb plus 1 minus t times 1 plus t c. So from here, guys, we're going to plug in the appropriate values of t to eliminate either our a's or b's so we can find all these constants, okay? So plugging in t equals 1, we can see both our b's and our c's will cancel. Because 1 minus 1 is 0, and 1 minus 1 again in this 1 minus t bracket is also 0. So we can have 0 times b plus 0 times c. So plugging in t equals 1, guys. Sorry, let me just move the chat. There we go. So plugging in t equals 1, he says, where's my mouse? Okay. So plugging in t equals 1, guys, we get left with 1 plus t, just on the a side, because everything else will be 0. So 1 plus 1 is 2, 2 squared is 4. So we have that 4a equals 1. Divide over by 4 to get our value for a. Our value for a is therefore a quarter, okay? So then we're going to plug in t equals minus 1, because we're going to want to eliminate the a's and the c's, just to be left with the b's. Because everything here will be equal to 0, everything here will be equal to 0, we get left with 1 minus minus 1, so that's 1 plus 1, it's 2, 2b. So 2b will be equal to 1. So we have that 2b equals 1 divided over by 2, we get b equals a half. So we have b. To find c, guys, you can remember, you can plug in any value of t you want. We tend to plug in 0 just because it's a little bit easier, okay? Tends to be a bit easier just to plug in 0. So let's do it. Plugging in 0, we have 1 plus 0, that's just 1, so 1 times a. 1 minus 0, that's just 1, 1 times b. Then plugging in 0 with our c, we have 1 minus 0, it's just 1. 1 plus 0, it's just 1, so that's 1 times 1, which is 1, times c. So we're just left with c. Therefore, our 1 on the left will be equal to a plus b plus c. Now we already know a, we already know b. So we have that 1 equals a quarter plus a half plus c. So we can quickly see that c will be a quarter. A quarter plus a quarter is a half plus a half gets us to that 1 that we need. Okay? So now we have a, b, and c. Remember, guys, with these partial fraction questions, they always want you to write out all the partial fractions formed. You can't just say that a equals a quarter, b equals a half, and c equals a quarter. You have to rewrite it as all of your partial fractions, okay? That's a very key thing. I think it's a bit stupid from the exam board because it's pretty clear what we're doing here, but you do have to do that. So we have that 1 over 1 minus t times 1 plus t squared is equivalent to or equals to a quarter over 1 minus t plus a half over 1 plus t squared plus a quarter over 1 plus t, okay? So from here, guys, we're going to have to integrate. Integrating partial fractions, we know we're going to be using that natural log where we can. We can't do it for all of these, but we can do it for some of them. So we have the integral upper limit of half, lower limit of minus a half, which is going to plug in all of these partial fractions that we just found into the integral. So integrating each thing, guys, remember, when we have our function differentiated on the numerator, we can take the natural log of our denominator. So differentiating 1 minus t, this would give us minus 1. We don't have minus 1 on the numerator, we have a quarter. So we'd have to do minus a quarter times by the natural log of 1 minus t to get that minus a quarter on the numerator. Then looking at our other thing where we can use the natural log, where we have that f of x on the denominator and f dash x on the numerator, differentiating 1 plus t would just be 1. We currently have a quarter, so we're just going to have a quarter times the natural log of 1 plus t, t plus 1, same thing. And then integrating this half over 1 plus t squared, we can't use partial fractions here, but we can rewrite this as 1 plus t to the power of minus 2. Bring that power up by 1, so we have 1 plus t to the power of minus 2. Bring it up by 1 to get 1 plus t to the power of minus 1. Okay, we're going to divide by minus 1, so we're going to have minus, because it's minus 1 times a half, so we're going to have minus a half, then we're left with 1 plus t to the minus 1. That's the same as writing 1 plus t in our denominator with that negative power. So we have minus a half over 1 plus t. Now the thing we have to be very careful here, guys, if I scroll up, before we plug in the limits, we can see they want the exact area of R. So we can't be plugging in all these decimal places with our natural logs. We have to write it as some constant plus the natural log of some number. We can't just be plugging everything into the calculator. You have to be pretty careful with these questions. So going back down, guys, if it lets me, there we go. Plugging in a half, we have minus a quarter. Natural log of 1 minus a half is just natural log of a half. Plus a quarter, 1 plus a half, it's 3 over 2. Take away half over 1 plus a half is over 3 over 2. So we have minus a half over 3 over 2. Plug in minus a half, I'm just going to go through this quickly. Minus a quarter, natural log of 1 minus a half, that's the natural log of 3 over 2. Plus a quarter times the natural log of 1 plus a half, so that's 1 minus a half, so that's plus a quarter of natural log of a half. Take away a half over 1 minus a half, so that's take away a half over half. We can simplify our constants here, guys. So we have minus a quarter ln a half plus a quarter ln 3 over 2 minus a third. Take away minus a quarter ln 3 over 2 plus a quarter ln half minus 1. Okay, so right now, guys, we can just add these normally, but once again, we're leaving everything in terms of a natural log. Okay, I do believe So adding these together, guys, we have minus a quarter ln a half minus a quarter ln half. So we have minus a quarter ln half, take away another quarter ln half, we're going to have minus a half ln of a half. Then we have a quarter of ln 3 over 2 minus a quarter ln 3 over 2. Two negatives, we're adding. So we have a quarter of ln 3 over 2 plus another quarter of ln 3 over 2. It's going to be half ln 3 over 2. Then we have minus a third minus minus 1. We're adding 1 minus the third plus 1 is 2/3. So we have minus a half ln 1 over 2 plus half ln 3 over 2 plus 2/3. Okay? From here, guys, we're going to use our log rules because this is not simplified. They want the exact area simplified. We know that when we have log A over B, so for example, log 1 over 2, we can rewrite this as log A minus log B. So we're going to have a half times or minus a half times ln 1 minus ln 2. Before I even carry on, we see ln 1, the natural log of 1. You got to think 0 immediately in this exam. Can't be wasting time. You see ln 1, you think 0. So we have minus a half times 0 minus ln 2 plus a half is going to be ln 3 minus ln 2. Once again, log A over B is log A minus log B. We haven't seen log rules come up yet. Very likely it's going to come up tomorrow. Could be in this kind of question, could be implicit differentiation. Then we're going to be adding over 2/3. So now expanding our brackets, guys, because that ln 1 is 0, minus a half times minus ln 2, that's just positive, so it would be half ln 2. Half times by ln 3 is plus half ln 3. Then we have a half multiplied by minus ln 2. It's going to be minus a half ln 2 plus 2/3. We can quickly see our half ln 2 minus a half ln 2. These will cancel out. So we get left, Pax is here every day, guys. So we get left with, if it lets me, we get left with a half ln 3 plus 2/3 because our ln 2s will cancel out. That's your final area for part B. Definitely long, definitely tricky, using those log rules and being very careful when expanding out. Very easy to make silly mistakes on these kind of questions. Yeah, Pax is aiming for that A star, I'll tell you that now. Alright guys, moving on to part B. Here we have a bit of Cartesian. With these parametric Cartesian equations, there tends to be three things you normally do. You can normally just rearrange for t, and then plug that value of t. So for example, here we would rearrange our x equation to find t equals something, then sub in whatever we found in terms of x into our y equation. You could potentially have to link the two via a trigonometric equation, or you may have to square both equations and add them together. These three things tend to be the things you have to do. It could be something else. Don't get intimidated. Just experiment around on the question. Don't get stressed. So anyway, we're going to determine a Cartesian equation of the curve in the form y equals f of x, and by evaluating a suitable integral in Cartesian, verify our answer to part A. So the integral is going to be quite easy because we know we're going to have y's and x's. So we can use these limits of x integrating with respect to x. So that won't be too tricky. Finding the Cartesian, also not too tricky. In this question, all we have to do is make t the subject of the formula and then plug it into our y parametric equation. Nothing crazy. So, carrying on. Sorry, someone just told me to start. I feel a bit bad now. So we want to eliminate t's when we're making a Cartesian. So we're going to make we're going to make t the subject of the formula, so we can plug in something in terms of x into our y parametric equation. Find the reciprocal of both sides. Tends to be a bit of a theme today, guys, but it's definitely good for these connected rates of change questions. So we have that 1 plus t equals 1 over x. Take away the 1 from the right-hand side, we have that t equals 1 over x minus 1. Sub this value of t into a y parametric equation. This leaves us with y equals 1 over 1 minus 1 over x minus 1. Okay? Well, 1 minus minus 1, that's the same as 1 plus 1, it's going to be 2. So we have that y equals 1 over 2 minus 1 over x. One thing I wanted to say, guys, in show that questions in A-level, or generally in just many worked questions, they tend to want you to get rid of denominators in these kind of questions. So here they would want you to multiply your denominator and numerator by x to get rid of that denominator within the denominator on that 1 over x. So multiplying through everything by x to get rid of that 1 over x, we get left with 1 times x in the numerator, it's just x. Then we have 2x, take away 1 over x times x is just 1. So we're left with y equals x over 2x minus 1. Now guys, how are we going to integrate this? We know our limits are going to be what they gave us in the question. Upper limit 2, lower limit 2/3. How can we integrate this? How are we going to integrate this? There are a couple of things you could do. But I'm just curious to hear what you guys would say. But I want to show you guys that there's more than one way to approach it. And don't get too stressed. Let me know what you guys are thinking. Let me know. The chat is a bit delayed for me, so I'm sorry if I'm responding a bit slowly. It does take like 30 seconds. I might just go through it. It takes 30 seconds for things to pop up for me. Alright, I'm just gonna go through it. Guys, we're gonna use partial fractions here. Okay? You could use integration by parts. You could use substitution that u equals 2x minus 1. I'll tell you now, guys, integration by parts you could not do. You could not do in A-level maths. You get left with the integral of like the natural log of 2x plus 1 or minus 1, I believe. It's disgusting. You could use u sub. U sub would work. Guys, quotient rule is differentiation. That's differentiation. We're integrating this. So we have the integral of 2 over 2 thirds of x over 2x minus 1 integrating with respect to x. So limit, sorry, of 2 and 2 thirds. Exactly, yeah, that is differentiation, but that's fine. So what we're going to do, guys, is you could use u sub, but we're here, because we haven't done it yet, we're going to use partial fractions. By parts wouldn't work in this question, it would be horrendous. You can try it, but it would give you the integral of ln. You could try it in the exam, but don't panic when you see that, just try a different method of integration. We are going to use partial fractions here, guys, but because we have our numerator the same order as the denominator, same order, all that means, guys, is we have x to the 1 and 2x also to the 1 to the power of 1, the numerator and denominator. This means we're going to have to do algebraic long division first. I would say this is the easiest way to integrate this, along with u sub. U sub also works, but we saw that in paper 1 already, so I'm going to be a bit cautious with that. So as the numerator and denominator have order 1, we use that algebraic long division. So dividing x by 2x plus 1, or 2x minus 1, how many times does 2x go into x? That would be a half. Then we do 2x multiplied by a half, gets us x, minus 1 times by a half, gets us minus a half. Taking away the bottom from the top, x minus x, those cancel out, we get 0. 0 minus a half is just a half. So we get left with a half plus a half over 2x minus 1, because that's our remainder, guys, okay? This is very key when we have those same order, or the numerator higher order than the denominator. We're going to have to use that long algebraic division to get it into the form of partial fractions. I believe we saw that in 2022 paper 2, where they wanted our function to be rewritten. So we have that x over 2x minus 1 is equivalent to a half plus half over 2x minus 1. This is quite a nice integral now. So once again, we have the limits. It's really being stubborn today. Okay, we have the limits. Upper limit 2, lower limit 2 thirds of a half plus a half over 2x minus 1 integrating with respect to x. A half is just a constant. Integrating with respect to x will be a half x. And then, like our partial fractions, we're going to be using the natural log. We know that 2x minus 1, if we differentiate that, it gives us 2. We don't have to. We have a half on the numerator. To get to 2 from a half, we'd have to multiply by 4. Or, in other words, to get to a half from 2, we'd have to times by a quarter. Okay, so we have half x plus a quarter natural log of 2x minus 1. And we plug in 2 and plug in 2 thirds. Plugging in 2, half times 2 is just 1, plus a quarter times 2 times 2 is 4. 4 take away 1 is 3. So we have a quarter times the natural log of 3. Remember, guys, we're trying to get the same answer as before, so we're going to keep everything in terms of ln with that exact value. Then for 2 thirds, plugging in 2 thirds, we have a half times by 2 thirds. That's just 2 over 6, which is a third. Then we have a quarter times the natural log of 2 times 2 thirds, 4 over 3, minus 1 is just a third. So same idea as before, guys. We want to try to get to that same answer. So we're going to be using those log rules again. So we have 1 take away a third. We can do that immediately. We know that's going to be 2 thirds. Then we have a quarter ln 3. Take away. Now we're going to use those log rules. Log a over b equals log a minus log b. So we have ln 1 take away ln 3. So we have minus a quarter times by ln 1 minus ln 3. Ln 1 instantly in that exam, we know that ln 1 equals 0. So we have minus a quarter times by minus ln 3. That's going to be plus a quarter ln 3. So that leaves us with 2 thirds plus a quarter ln 3 plus another quarter ln 3. That's going to be a half ln 3. So we have 2 thirds plus a half ln 3, exactly as we had before. Where did I get the limits? The limits were given in the question. Because it's a Cartesian equation, we can just use the x limits, and they gave us the x limits in the equation. Upper limit 2, lower limit 2 thirds. Let me know if you guys have any questions on that parametric integration. Definitely a good question. Definitely the kind of thing that we could see tomorrow. We had finding the Cartesian, integrating the Cartesian, parametric integration. Yeah, I mean, changing the limits, multiplying by minus 1 to flip those limits. All important stuff. Thumbs up if we're happy to go on to the next question, or let me know if you guys have any questions. But the limits were given in the question, so that was that. I hope that's all good, guys. I hope that's all good. Make sure everything's good. Okay, we are still running, guys. My laptop is getting very hot, so I'm a little bit worried. Guys, thumbs up if you want me to move on. I believe the next question. I'm seeing some thumbs up already. Oh yeah, guys. Next question is trig modeling. Pax is happy. Pax is really happy. That's good. Yeah, I hope this question is fine, guys. I would definitely be careful when finding Cartesian equations. They can be trickier than this. But if you're stuck, I would say the first thing you should do is just try make t the subject of a formula, then sub it to y. How many marks is this? This could be a lot of marks, to be honest. This could be like 12 marks. It's a long question. You could have used U sub. U sub would have been fine. U sub would have been fine. I just wanted to show the partial fraction way. I would say if it comes up tomorrow, they may ask you to get it into a certain form using algebraic division. So then you can use your partial fraction integration. It might not be in this form, but it could be in some form. We don't know what they're going to ask, but we can try and make a good guess. Yeah, U sub would have been fine. It would have been fine. By parts would have been the bad one. If you used by parts, you would have got stuck, and then you'd have to not panic and then try a different method. Don't panic, guys, if your way of integrating doesn't work the first time. But they tend to give you hints in the question what they want you to do. And normally they tell you to use U sub if you have to use U sub. We saw that in the last paper, so don't overthink that one. I'm seeing quite a few thumbs up. Guys, let me know if you want me to move on or not. I'm going to put up the next question just while we wait. Quick sip of water. Okay, bit of trig modeling, guys, bit of trig modeling. It's a good question, to be fair. Remember, guys, in trig modeling, we're always using the fact, whether it be in part C, part B, whatever it is, that sine and cos are bounded by -1 and 1. That's always got to be in your mind. Let me know if we're happy to move on, guys. Let me know if we're happy to move on. If I get one thumbs up, I'm just gonna go. Yeah, trig modeling almost guaranteed to come up tomorrow. Like I said, partial fractions, differential equations, trig modeling, some differentiation, product, quotient rule, all very, very likely to come up. We're also going to go all questions answered in my head. I love these type of questions. Yeah, I'm going to go through it a little bit slower. I know with these trig modeling questions, a lot of you guys can do this very quickly, instantly. Okay, I'm seeing a thumbs up. Let's go. I know a lot of you guys can do this very quickly, but I'm going to go through this step by step. I apologize. I just really want everything to be clear for these trig modeling questions. So we have to express 12 sine x minus 5 cos x. Yeah, range and domain as well. Range and domain is very likely to come up. I've done a few videos on those recently, and we also did it in previous live streams. So we have to express 12 sine x minus 5 cos x in the form of r times sine x minus alpha. R and alpha are constants. We're told that r is larger than 0, and alpha must be larger than 0 and less than pi over 2. Give the exact value of r and give the value of alpha in radians. We know it's going to be radians because they tell us between 0 and pi over 2, and the alpha in radians is to 3 decimal places, okay? So part A, I know you guys will do this very, very quickly, but let's just go through it. For trig modeling, we're going to use our sine addition formula. We have sine A minus B, so we're going to use sine A cos B, take away cos A sine B, where our A will be x and our B will be alpha, okay? I know this is a bit slow, I know you can do this quickly, but here we go. So sine A minus B is equivalent to sine A cos B minus cos A sine B. So we're going to have sine x, x is our A, B is our alpha. Sine x cos x minus cos x sine alpha. Expand out the brackets by r, so we're going to have r sine x cos alpha, take away r cos x sine alpha. Now when we have this, we're going to compare it to what we had in the question, 12 sine x minus 5 cos alpha. So comparing it, we know that r cos alpha must be equal to 12 and r sine alpha must be equal to 5. From here, we're going to square each equation and add them together. Squaring each equation, adding them together, we have r squared cos squared alpha equals 12 squared, 144. And then we have the r squared sine squared alpha equals 5 squared, 25. Now we're going to add them together, guys. We have the r squared cos squared alpha plus r squared sine squared alpha equals 144 plus 25. That's 169. Factor out the r squared because we know that cos squared alpha plus sine squared alpha equals 1. This has to be instant. I know you guys can immediately just square the 12 and square the 5 and then square root it. So add them together and square root it. But I just want to explain why we're doing what we're doing. Okay? So we know this all equals 1. So r squared will be equal to 169. So then we square root 169 just to get r. Because we know r must be larger than 0, we can ignore that negative square root. So r is equal to 13. So that's our value of r. All we have to do now, guys, is plug this value of r into either our r cos alpha or our r sine alpha equation, and then we can rearrange it to find alpha. So what did I choose to do? I chose to use the sine alpha equation. You can use either one. So plugging in r equals 13, we have that cos alpha equals 12 over 13 and sine alpha equals 5 over 13. Now we can either inverse cos 12 over 13 or inverse sine 5 over 13. I decided to inverse sine 5 over 13. So we get 0.395 to 3 decimal places. Make sure we're in radians when answering that question. Okay, very, very important to be in radians. Sorry guys, just making sure my laptop isn't burning up. Alright. So we found alpha to be 0.395 and we have r to be 13. Let's move on to part B. So part B of this question, we're told that the function g is defined by g of theta equals 10 times, 10 plus 12 sine of 2 theta minus pi over 6 minus cos 2 theta minus pi over 6, where theta must be larger than 0. Okay? Immediately seeing this, guys, I see 12 sine of something minus 5 cos of something, and in these trig modeling questions, they always want you to use your answer to part A. But what's the difference? This time, instead of x, we have 2 theta minus pi over 6. Don't get intimidated by all that. All we're doing is instead of having that x in our 13 sine x minus, what was it, 0.395, I believe, 3.59. So instead of having it 395, so instead of having that, we're going to have our x value to be 2 theta minus pi over 6. Okay? So let's just rewrite our function g of theta like that. Now, Neil does maths is significantly better than me, but I'll do my best, guys, to help you out. So exactly that, guys, we rewrite it using what we found in part A. Instead of x, we have 2 theta minus pi over 6. So we rewrite g of theta to be 10 plus 13 times sine of 2 theta minus pi over 6, take away 0.395. Okay? We want to find the minimum value of g, guys. So this is where they try to trick you. A lot of people get stressed. They see this massive thing inside of our brackets, we get all stressed. Okay? We do not need to stress, guys. The key bit of information in these questions is we know that sine and cos, whatever it may be, is bounded by -1 and 1. Neil makes mistakes. Neil does not make mistakes. Neil is perfect. I make mistakes. So we need to find them. No, I don't make mistakes, guys. Not here, not here, not on this stream. So we have to consider the sine function in isolation. As I said, we know that sine of whatever the input is, don't stress about what's in the input. Whatever's in the input must be larger than or equal to -1, less than or equal to 1. We know the minimum value of sine is -1. So we can do 10 times 13 times -1. So 10 times 13 times -1, that's 10 minus 13, gives us -3. Okay? So that's your minimum value of g of theta, just using the fact that sine can be minimum -1, so that's the minimum possible value that we can achieve of our function. If this was -13 sine of whatever, we'd be considering sine equals 1, because that would give us the minimum value. Same idea here. Alright guys, now all we have to do is find the smallest value of theta. This tends to be the follow-up of this question. Find the smallest value of theta where this occurs. So we need all of that thing, that sine of all of this in the inside, equal to -1. Okay? Now a bit of key information here, guys. So we have the sine of 2 theta minus pi over 6 minus 0.395 is equal to -1. We're going to inverse sine of -1. But looking back at the question, it tells us that theta must be larger than 0. Okay? So because theta must be larger than 0, we know there are infinite times where our sine graph will be equal to -1, guys. We know this, yeah? I'll quickly draw it out as well. We have our sine graph. This is a horrendous sine graph. Just drawing it out over and over and over. And also on the negative side, there'll be all these points where we get -1, okay? But because they wanted the smallest value of theta, and under the condition that theta is larger than 0, it is also the first value your calculator gives, I believe. I can check that quickly. We inverse sine of -1. It doesn't. It gives you minus pi over 2. So this is where you have to be careful. Theta must be larger than 0. So the smallest value of theta, satisfying this, must be theta equals to 3 over 2 pi. Okay? So we set theta equal to 3 over 2 pi, add over the 0.395, add over the pi over 6, and divide by 2. Just GCSE rearranging, guys. For this one, yeah, you can just plug it into a calculator, nothing scary. To 3 significant figures, because I believe that's what they wanted, we have that theta equals 2.82. Okay? Nothing scary. We're just using the fact that sine is bounded by 1 and -1, and then we have to find what everything on the inside must be to get the arcsine of -1. Okay? Nothing scary. There tends to be this kind of question. It won't be many marks, but it's important. Now, this last bit, a lot of people will make mistakes on this last bit of the question, guys. Okay, so be careful with this stuff. We're told the function h is defined by h of beta equals 10 minus 12 sine beta minus 5 cos beta all squared. Okay, so once again, we're going to be using answer to part A. You have to see that instantly. So we're going to be using that 13 sine of alpha, or in this case beta, sine of beta minus that 0.395. Okay, so let's make that substitution in immediately, and then we're going to square it. Let's go all the way back down. We made that sub in using our part A again. So we have that h of beta equals 10 minus, not sure why I double bracketed, 13 sine of beta minus 0.395 all squared. We're going to square all this stuff, guys. 13 squared, 169. Then we have sine squared of beta minus 0.395. Okay, so we're going to rewrite it like that. Now, here's the key thing, guys. We are trying to find the range of h of beta. Yeah. So a lot of people here, because of that adrenaline in the exam, getting nervous, we're immediately thinking -1 and 1 again. Okay? That's not the case. Because we know sine is bounded by -1 and 1, normally we would just plug those in. But here we have sine squared. We know that anything squared must be larger than or equal to 0. So the smallest value of sine of whatever can take squared will be 0. Okay? Because anything else will be positive because it's squared. And then once again, -1 and 1, both the minimum and the maximum values squared, would both be 1. Okay? So you actually don't have to stress too much about the maximum value. We know it's going to be 1, but the minimum value is 0. That's kind of the little trick that makes a lot of people panic in these kind of questions in the exam. So exactly that, guys. We know that sine is bounded by -1 and 1. Sine squared, however, is bounded by 0 and -1. So if we want the minimum possible value of this, we're going to want to take away as much as we can from 10. So we're going to do 169 multiplied by the maximum value of sine, which is 1, or sine squared, which is 1. So we do 10 minus 169 for that minimum value to be minus 159. Now, the largest this possible value could be, because we're taking away 169 times some positive number, we want it to be 0. Because we want to take away nothing if we can, right? So that would be 10 minus 169 times 0, plugging in that minimum value. So that's going to be 10 minus 0, which is going to be 10. So therefore, we have h of beta must be larger than or equal to 159. Remember, it can be equal to, because sine can be equal, or sine squared can be equal to 1, and less than or equal to 10. Same idea, it can be equal to 0. Let me know if you guys have any questions on this. If not, I'm going to move on. I've got 2 more questions. They are both geometric series questions. And I did want to clarify something about cobweb and staircase diagrams. It only comes up for a mark or 2, but I just wanted to be very clear on what you have to do, because I had a couple of questions on it. If you got 89 out of 100 in paper 1, no, 89 out of 100 in paper 1 is already it's already a very good score. I mean, you're well in an A star. Just be consistent now. So guys, thumbs up if you want the next question, or ask me any questions if that didn't make sense. Pax is happy. Pax is happy. Yeah, guys, this is the kind of question a lot of people would make mistakes on. Either getting intimidated by everything inside the brackets, or with the sine squared plugging in -1. So definitely be careful with these kind of questions. They like to do these little things. They love to use the fact that something squared is larger than or equal to 0, and people in the rush and stress of the exam tend to just miss that out. Okay? So definitely be careful. With trig modeling, remember it could be a multiple, or your angle could be doubled or halved or times by 4. Whatever it is, it will be using your answer to part A. Okay, Fred gives a thumb. Fred gives a thumb. That's great to hear, Fred. I'll put on the next question, guys. Yeah, I'm addressing this question just because I know people hate this summation notation. I want people to get calm by it. I just want to clarify a few things. This question is a little bit too abstract for the exam, so I have a second question after this one, still on geometric series, just to be very clear. I'm going to leave this up for just a second. Ensure the stream is not breaking, because my fingers burn every time I type. Okay. Alright. I see people are quite happy to go. So the geometric series question, guys, horrible notation, but I'm going to try and make this seem okay. Just give it a second, guys. Let me know if you guys. Okay, I'm seeing a few thumbs up already. Right, geometric series. It's given that r is larger than 0 and less than 1, and r, big R, is less than or greater than 0 and less than 1. Okay, and r is less than 2r. These are just the conditions, so all of these expansions are completely fine when we use our sum to infinity. That's exactly what we're going to be using in this question, guys. We're told the summation from n equals 0 to n equals infinity of r to the power of n is equal to the sum to infinity. That's all you got to see, guys. Do not get intimidated by this notation. When you see that infinity, we know we're going to have a sum to infinity. Okay, going to be using that formula that we all know. But we have the summation from n equals 0 to infinity of r to the n, big R to the n, equal to summation n equals 0 to infinity of little r to the n, all squared. Okay? So I'm just going to write this out, guys. Don't get intimidated with this stuff. All it is we're using the sum to infinity. Now, quickly going through it, let me just quickly draw this out, guys. With these questions in general, they may want you to use like a log rule or something, as we saw in a past paper. It may not be completely obvious what they want you to do immediately. I'd always recommend just writing out a few terms. These are really horrible writing, guys. But remember, because we both have sum to infinities in both of the terms, we're just going to use our formula of a over 1 minus r, where r is the common ratio and a is the first term. Okay? So there's nothing scary there. Writing out a couple terms, just plug in the first value of n. We know n equals 0, so that first term will be r to the power of 0. Anything to the power of 0 is 1, and then from there, we'd have r to the power of 1, well, it's the series, sorry guys, we're adding. We'd have r to the power of 2, and so on. So we can see each time that common ratio will just be big R. So our left-hand side of the equation will simply be 1 as our first term over 1 minus big R. Okay? Nothing scary here, guys. And we're going to be using this logic also for the right-hand side. We can see the right-hand side within the brackets. It's just going to be the exact same thing, but instead of the little r, we'll have the big R. All I'm trying to show, guys, is when we see that sum to infinity, or when we see that infinity on top of our weird summation notation, we're going to be using the sum to infinity. So just writing it out, guys, we have 1 over 1 minus r, as I showed on the left-hand side. That inside the brackets, same idea with little r, but we have to square the whole thing. So squaring the whole thing, we have 1 over 1 minus r all squared. 1 squared is 1, so this is the same as writing 1 over 1 minus r is equal to 1 over 1 minus r squared. We can find the reciprocal of both sides here. Quickly, guys, the reason we're trying to rearrange this is because looking at our answer, we have to show clearly that the summation from n equals 0 to infinity of r over 2r to the n equals 2 times 2 minus r over 3 minus 2r. Everything is in terms of r. We don't have any big r's. So using this information, we're going to have to rearrange to make big R the subject of the formula, so we can plug in little r into this equation here. Okay? Nothing scary, guys. Nothing scary when you see the summation. This is very friendly. It's all sum to infinities. Realistically, this would be one part of the question, but let's just go through it. So exactly that, guys. We have the 1 over 1 minus r equals, if it lets me scroll down, equals 1 over 1 minus r squared. Find the reciprocal both sides and expand out this brackets. That's going to be 1 minus 2r plus r squared. So we have 1 minus r equal to 1 minus 2r plus r squared. Take away 1 from the right hand side. These ones cancel. So we have that minus r equals minus 2r plus r squared times both sides by minus 1. So we have that r equals 2r minus r squared. Okay? So now we have r equals 2r minus r squared. We're going to be able to use that when going through our actual answer here. Okay? So same idea of our actual answer, guys. The first term, plug in n equals 0. Always write out a few terms in these general types of questions, guys. Okay? So plugging in n equals 0, anything to the power of 0 is 1. So we know the first term is going to be 1. And same logic as before, that common ratio will just be r over 2r. So we can just plug those into our sum to infinity. If it lets me. Sorry, guys. Technical issues. Okay. First term 1, ratio r over 2r. I would say in these questions, write out the first few terms. It may not be so obvious, and you may be able to see a recurring pattern where terms will cancel out, like we saw in that log question in a past paper. So I definitely recommend to do that in general. But in this question, we can't do that. It's just sum to infinities. So we have 1 over, 1 minus, then that common ratio of r over 2r. We're going to multiply through by 2r. In these show that questions, once again, they love you to get rid of these denominators within either your numerator or denominator. So multiplying everything through by 2r, we'd have 2r on the numerator, then 2r minus r on the denominator. Now from here, we're going to use that substitution because once again, our answer doesn't have capital R, it only has a little r. So we're using 2r minus r squared wherever we have r. We have 2 times 2r minus r squared over 2 times 2r minus r squared, take away r. That's just kind of similar to what we have, kind of similar, we're getting there. We can see single r's. None of these are squared. We can quickly see, going back down, that we have loads of r's on the numerator and on the denominator. In fact, we can actually divide it through by r. So we would have 2 times Remember, guys, we're not going to expand these brackets because once again, sorry for all the scrolling. Once again, they leave that bracket unexpanded in the numerator, then we are going to have to expand in the denominator. So always spot the difference between what we're using and what we're trying to get to. Okay? So not expanding out that numerator, we could factor out that r if it lets me. Okay, exactly. We could factor out the r, that would cancel with the r's in our denominator. So we'd be left with 2 times 2 minus r instead of 2r minus r squared. We now have 2 minus r. Then in the denominator, we're now going to have 2 times 2 minus r, once again cancelling these r's out, take away 1. Okay? From here, as I said, they want us to expand on the denominator. 2 times 2 is 4. 2 times minus r is minus 2r. We have 4 minus 1, that's going to be 3. So 2 multiplied by 2 minus r in the numerator over 3 minus 2r in the denominator, exactly as required. Let me know if we're happy with that question, guys. Let me know if we're happy. TikTok's making me do one of those sliding things. Okay, cool. Let me know if we're happy with that question. I have another geometric series. I just really wanted it to be clear about all of this summation notation. I don't want you guys to get scared when you see this or if it comes up, but if it does come up, it should be 3 marks. Because they simply do it to intimidate people. A lot of people see this notation, they get scared, they run off. But this is just repeating sum to infinity. Looks like we're happy, looks like we're pretty happy. Unlikely to come up, right? Even though the knowledge understanding is useful. Unlikely to come up, but the geometric series very likely to come up, and the usage of sum to infinity also likely to come up. So I feel like this does address a few key topics. Yeah, you wouldn't get this in the paper. That's why I have a second geometric series question, which is more relevant. Just wanted to show you guys this kind of question with that summation and the idea of writing out terms. I want that to be fresh in your head. So if you see this stuff, you don't panic. You just write out a few terms. Exactly. Just writing out the formula and write the terms out. Exactly that. So here we have a little bit of binomial expansion. I've seen everyone only be doing second year binomial expansion. I have some first year binomial stuff just because we've done a lot of second year stuff, either on my videos or on live streams, and I've seen other tutors do it. So just the first year binomial expansion. And then we're going to do a more realistic geometric series question, which has a bit of trig into it. They love trig. I think we see like 20 marks every year a trig. So even though decent amount came up in paper 1, you're going to see more in paper 2. Maybe not a lot, but we'll see. Gonna wait just a second, guys. Gonna wait just a second before going through this. Thing is, you guys have done paper 1 already, so all of this stuff you guys were already prepared for. So if you're feeling stressed, don't feel stressed. I'm sure you guys are all ready for this stuff because all of this could have come up in paper 1 and you would have been fine. I'm sure you would have been fine. Yeah, exactly. A lot of people don't see year 1 binomials. There's so much emphasis on year 2 with the negative and fractional indices that people tend to forget to do the year 1. The formula is in the formula book, so don't stress too much. But should know it, right? Like it should be one of those things that should be 3 marks. Some people might panic and not get it. Alright guys, we have 3 plus 2x to the power of 6. Using the formula, we know that a plus b to the power of n is simply just n choose r, a to the n plus n. I'm not going to read out the whole formula, guys. I was just going to say that we have a to the n, then we take away 1 from the power each time, then we have b to the n minus r, and we're going to be adding 1 to that power every single time, okay? Where our a value, there we are, our a value is 3, and our b value is 2x. The power of n is to the power of 6. They want the second, third, and fifth terms because we're going to use that in our geometric sequence, the geometric series. You can use the year 2 formula, but sometimes people panic. Sometimes people panic and they won't factor out that 3, for example, and they'll just see this and they kind of get a little bit worried. They think, oh, it's not fractional negative indices. They forget to factor out the 3 to get in that form of 1 plus something or 1 minus ax, and then people panic. So I think it's very key just to be looking at this before the exam and just understanding. So exactly that, guys. Just plug it into your formula. I'm not going to go through all this. It's just using the formula. I just wanted you guys to have seen it before the exam. We have the second term, 6 choose 1, 3 to the 5 multiplied by 2x. Then our third term, 6 choose 2, 3 to the 4 multiplied by 2x all squared. Remember, the whole thing is squared. So this is going to be 4x squared. And then for that fifth term, we have 6 choose 4, 3 squared multiplied by 2x to the power of 4. Okay? Not wasting time on this one, guys. This gives us, for the second term, 2916x 4860x squared, 2160x to the 4. I didn't really want to spend too much time on that question because I think the next part of the geometric series is more valuable. Okay, we're told for a particular value of x, these three terms, the second, third, and fifth term that we just found, form consecutive terms in a geometric series. Okay, guys? So remember, with a geometric series, we have that common ratio, guys. We have a common ratio. If we have a common ratio, just quickly rubbing all this stuff out, it means if we do our second term, let's call it A2, over our first term, this ratio will be equal to our third term over our second term. Okay, I know these are disgusting A's. I hope you get the idea. The ratio will always be the same. The next term divided by the previous term will be consistent throughout. Okay, so because it's consistent throughout, we can simply just take the terms that we found in part A, then divide them. So doing that second term over the first term, 4,860x squared over 2,916x equal to 2,160x to the 4 over 4,860x squared. Well, x squared over x, that's just x. Then x to the 4 over x squared is just x squared. Now remember, we don't care about the solution x equals 0, so we can just divide through by x. We don't want 0 to be the common ratio, so we can divide through by x. I know we had a lot of discussion last time with different examples. In this case, you can do it. So we have that 5 over 3 equals 4 over 9x. Then divide over by 4 over 9, or multiply by 9, divide by 4, however you want to think of it. We have that x equals 15 over 4. Just put it in your calculator. So we found the corresponding value of x by knowing that we have a common ratio and using our answers to part A, dividing through by x, because we know that we don't have to care about our solution of x equals 0. Okay, so nothing scary there, guys. Then we're told in a different geometric series, the first term is sine squared x, the common ratio is 2 cos theta. This is great, we have the first term and the common ratio. We're also told the sum to infinity is 8 over 5. This is a more realistic question, nothing too tricky, but you still have to use that sum to infinity formula. We have to show that 5 cos squared theta minus 16 cos theta plus 3 equals 0. And then we have to find the exact value of the second term in the series for part B. Let's just go through part A first. For part A, we're literally just going to use the values that they give us. Just going to plug it into that sum to infinity formula. So exactly that, guys. First term is sine squared theta. Common ratio is 2 cos theta. And we're told that a over 1 minus r, the sum to infinity, equals 8 over 5. So just plug it in, guys. But quickly seeing, guys, going back to the top, they want everything in terms of cos theta. We currently have sine squared theta. Using that trigonometric identity, sine squared plus cos squared equals 1. So sine squared equals 1 minus cos squared. So we're going to use that trigonometric identity when trying to find this quadratic. Okay? We're trying to find this quadratic, guys. We plug in 1 minus cos squared theta instead of that sine squared theta. We set it equal to 8 over 5. We multiply that left-hand side by 5 to get 5 minus 5 cos squared theta. Then the right-hand side by 1 minus 2 cos theta. Oh yeah, I'll do this. Sorry, guys. There you go. All right. So we have 8 minus 16 cos theta equal to 5 minus 5 cos squared theta. Now we can just rearrange, add over the 5 cos squared theta, take away the 5, 8 minus 5 is 3. That leaves us with 5 cos squared theta minus 16 cos theta plus 3. Nothing horrible here, guys. Moving on to part C, or part B, sorry, we have to find the exact value of the second term of the sequence. Remember, geometric series, to find the nth term, it's just going to be a times r to the n minus 1. Okay? So a times r to the n minus 1, they want the second term. Oh yeah, shit. First thing we have to do, guys, is find value for x. We're trying to solve cos theta, right? Because we're trying to find... Sorry guys, just checking the channel. Everything started lagging a lot for me. Let me know if it's lagging for you. Looks like we're all good. Guys, give me a thumbs up if you can hear and see me. My laptop is getting very hot. Give me a thumbs up, give me a thumbs up. I think we're all good at that. I'm just gonna, can a question be what a geometric series? Okay, you guys are giving me chat, so I assume it's all fine. So we want to find the second term in this series. To find the second term, we're gonna have to find the value of cos theta, okay? Because we want to find the ratio. So to find the value of cos theta, we're gonna solve this quadratic, okay? All good, okay, cool. So to find the value of cos theta, we're gonna solve the quadratic. We're gonna use the substitution. If you want to, guys, a lot of you guys won't even need to do this. We're gonna use the sub of x equals cos theta. So we have 5x squared minus 16x plus 3. See what multiplies together to make 15, adds together to make minus 16, then simplify. Or you can just put the quadratic into your calculator. We have x minus 3 and 5x minus 1. Remember, that means that x equals 3 and x equals a fifth, but remember, x equals cos theta. So we have either that cos theta equals 3, cos theta equals a fifth. However, we know that cos is bounded by, I'm repeating this over and over because it's probably going to come up, this idea, either in trig modeling or a question like this. We know that cos theta must be bounded by minus 1 and 1, so we can only have the solution of cos theta equals a fifth. Okay? We know to find the nth term of a geometric series, this would be a times r to the power of n minus 1. Now going back up to the question, what did they want, guys? They wanted the second term of the series. So it's going to be a times r to the power of 2 minus 1. 2 minus 1 is just 1. So it's a times r to the power of r to the power of 1, just a times r. Now we already know the first term is sine squared theta. They tell us in the question. We also know the common ratio, is 2 cos theta. This is good. We know that cos theta is a fifth, and we know we have a trigonometric identity that can connect sine squared theta to cos squared theta. So because sine squared theta equals 1 minus cos squared theta, we multiply this by 2 cos theta. Okay? Now all we have to do is sub in a fifth into cos theta. So we have 1 take away a fifth squared. Fifth squared is just 1 over 25. Then we have 2 cos theta. Cos theta is a fifth, so it's going to be multiplied by 2 times a fifth. So we have 1 minus 1 over 25, 24 over 25, multiplied by 2 fifths. Put it in the calculator, gets you 48 over 125 for your second term. Okay? Hope that makes sense, guys. Hope that makes sense. Let me know if you guys have any questions on that. All we're doing is solving this quadratic to then find that second term. Because we get that solution for cos theta, can plug it back into what we know to be the first term, we know to be the common ratio, because we know to find the nth term, we do a to the power, so a multiplied by r to the power of n minus 1. So once we find r, once we find a, we know we have this cos theta, and we know we can get sine squared theta in terms of cos theta, we can use a solution. Yeah, you could find the solution for theta and then sub it in. I just sometimes like to leave it as the trig identity when we have nice numbers. So then it just looks a little bit cleaner, looks a bit nicer. It tends to be a bit more friendly, and sometimes if you want to plug every single decimal place in into your next answer, it might not get you exactly what you want. So if you're storing the answer on your calculator, that's definitely fine. Guys, there's one more thing I want to address. One more thing I want to address. Yeah, you could do that. You could do that. With your cobweb, that is your final answer, guys. Final answer for your second term is 48 over 125. Guys, with the cobweb and the staircase diagram, I just want to say one thing. Because I had someone asking me about this line. As we know, we go curve line, curve line, curve line. But people ask, why do we use cobweb? Why do we use staircase? We use staircase when our curve has a positive gradient, and we use cobweb when it has a negative gradient. I'm going to do my best to make sure this is convergent, because this could be very close to being divergent. So as we know, we go to the curve. So whenever we're going to the curve, we're moving vertically, guys. We're moving vertically when we go to the curve. We go to the line, we then go to the line. We move horizontally, okay? And same thing again, we go back to the curve. You're going vertically and then going horizontally to the line. Curve line, curve line, curve line. It's always curve line. But then with the cobweb, if we had a curve with a negative gradient, I'm going to be really careful to not make divergent. Just do that. Let's say our root is here. So we go curve, and once we're at the curve, we're moving horizontally. Moving horizontally, go to the line y equals x, back to the curve, back to the line, back to the curve. So we're going to the curve, we're moving vertically, and we're going to the line, we're moving horizontally. And we're going to use that cobweb when our curve has a negative gradient. It will normally tell you in the question what to use, and it will be obvious that only one will converge to the answer you're trying to get to that root. However, when you have a positive gradient, it's going to be staircase. It could be going down the staircase as well, but in this case, it's going up, depending where your root started. I hope that makes sense, guys. I just want to clarify. I know it's only like 2 marks or 1 mark. Just had a couple questions about that. I don't have any questions of the cobweb. The only question I've seen was the one in the past paper. Most of the times I don't see any cobweb or staircase. Just ever since that past paper question, everyone's been a little bit worried about it. I just wanted to clarify that's why you use staircase and why you use cobweb. But in general, it tends to be obvious. And there's a good chance it won't come up because now that people have seen it, it is just that same logic, curve line, curve line, curve line. Guys, that is all the questions I have today. This document is available in the bio, I believe, of my TikTok. Please like and subscribe if the videos or the streams were helpful. I'm sure all of you guys will be fine for paper one. I'm sure you will be fine for sure. If you're doing all these streams, watching videos of all math tutors, you should be fine. It's come up once and that's it. Yeah, it has only come up once, but you never know, guys. Here we have the Bison Maths description, I believe, of one of his predicted videos, and the Mr. Asprey predicted topics as well. I've seen that iteration question about how there's a tangent to a curve. Passing, you've got to find its point on the curve. I'm not sure what you're referring to. Because, I mean, if you've the thing is, with A-Level Maths, if you've seen the question and it comes up again, it's 3 marks. So, guys, I think we're done here. I think we're done. I'm just gonna go for 1 more minute. Let me know if you guys have any questions about the parametric integration, trig modeling, any of the geometric series. Yeah, don't get stressed about the summation thing I showed you guys. I just want you to not be intimidated and spot if you see that sum to infinity on the top of your summation notation. It's nothing scary though. Looks like we're all good, guys. I think I'm going to be ending the stream. I do wish you guys the best of luck for tomorrow. You know, after tomorrow, no more pure maths, unless you're doing a maths degree. No more pure maths for A level at least, which is really good. How long will my stats and mechanics be for? I'm only doing stats, guys. I'm only doing stats. I think I'll be most helpful by just doing stats because that's my focus. I quite enjoy stats. If you want mechanics, don't come to me. To be honest, but stats will be very easy. I want to explain it very simply, make these binomial and normal approximations seem logical. I hope you have a large data set, key things to remember. But yeah, I hope that's helpful, guys. I wish you the best of luck in the exams. I'm sure you will be fine if you're doing you won't miss pure. Trust me, once it's over, you guys will be more than happy it's done. But that's it, guys. Thank you for joining the stream. Sorry. Please subscribe if these have been